Hello and welcome. My name is Luis Orozco. I'm a DePaul University student, and today I will be presenting on my IPD 451 Big Data and NoSQL final project, which revolves around NBA Raptor analytics. The central focus of my project can be summarized with the following problem statement. It is the National Basketball Association offseason, and you are the general manager of your team. You are tasked with evaluating your current roster, free agents, and any players you can trade for to better your team this summer, and to eventually compete for a championship the next season. You will use Raptor to accomplish this. So, what is Raptor? Raptor is an acronym that stands for Robust Algorithm Using Player Tracking and On-Off Ratings. Raptor is a relatively new plus-minus statistical method that reflects how NBA players are evaluated by front offices for net performance. It was first developed by 538, and its predecessor, named Carmelo, was essentially its 1.0 version. Raptor improves on Carmelo by incorporating variables such as player height, age, draft position, awards, etc., all into the algorithm. So, Raptor measures the number of points an NBA player contributes to their team offense and team defense per 100 possessions, relative to league average figures. So, for example, if a player has an offensive Raptor rating of plus 2.5, this means that they improve their team's offense by 2.5 points per 100 offensive possessions. Similarly, if a player has a defensive Raptor rating of negative 1.5, this means that they diminish their team's defense by 1.5 points per 100 possessions while they are on the court. There's also a third general stat, which is Raptor total, which essentially just joins both offensive and defensive Raptor ratings. So the player above would have a Raptor total of plus 1.0. So where did the data come from? The Raptor data was downloaded directly from 538's website, which essentially serves as a data repository for many sports-related datasets. The following is the direct URL source. Multiple Raptor dataset options were available in .csv format for download. They are seen in the screenshot below. The chosen datasets for this project are those files ending in _by_team.csv. MongoDB, the chosen tool for this project, allows the importing of various different files containing documents of all varying degrees of schemas or formatting. Tools such as these, along with others down or later on in the data ingestion pipeline, allow for the relatively seamless merging of these data sets. If you want to have a more comprehensive data set, which includes files from all different kinds of sources or different formatting. To the right are a couple of screenshots of what the process looks like when first importing data into a collection within MongoDB. Now, we're going to take a quick look at what the raw data looks like. Below is a sample screenshot of one of the data sources, particularly the modern era by team.csv file, um, essentially showing columns A through K, but there are a total of 23 columns, a few not showing in the screenshot for space purposes. And this particular file has a total of 167,652 rows, or in this case, documents to work with within MongoDB Compass. And as mentioned previously, we will be leveraging a few tools to do some of our big data and analytical work for this project. The big data solution of choice is MongoDB, particularly the MongoDB graphical user interface, MongoDB Compass. Additionally, for visualization and analytical work, we will use Tableau software. And to the right is just a sample document object as it is seen in or within MongoDB, just showing a few of the Raptor analytics that we are interested in for a particular player, in this case, the late Kobe Bryant. this slide is dedicated to this project's big data architecture diagram. Essentially, what this diagram portrays is what is included in its back end and front end of the architecture. The back end including all the different kind of data ingestion operations. What are those data sources exactly? But more specifically, what are the ETL or transformation processes of that ingested data? Here is where we see our MongoDB Compass and Tableau, and specifically Tableau Prep tools being called out, along with other ETL management services. Afterwards, this same data is then stored in what could be data marts or a data warehouse for later retrieval or by end users, in this case, the general manager or the front office employees. And this is where the front end, where they interact with the front end, I should say, through a BI portal or a graphical user interface, in which case this could be Tableau or Tableau Server or various other BI tools. So how is the data for this project analyzed? There are a variety of questions that can be explored and answered based on the collected data thus far. Now, we can explore some possible data analysis use cases, followed by some visualizations on the Tableau platform. Some sample queries, primarily on the MongoDB Compass GUI, and accompanying visuals on Tableau, are included with example use cases in the following slides. In practice, end users like the general manager or the front office employees would be able to query the data directly on the database interface of choice, such as on a GUI or a shell, and create their own visuals on a data visualization tool like Tableau, Power BI, Excel, etc. Now we begin our data analysis and our review of the results and findings we find from stat analysis. Our first use case is you as the GM for the Chicago Bulls, and you would like to see your current player roster. So on MongoDB, you can input the following parameters as seen in the gray screenshot to the left, and you would eventually get the results that you can start to see at the bottom of the screenshot. You can start to see your players, other interesting statistics, and the beginning of the Raptor statistics that this project revolves around. And just a note, RS in this case, and for the rest of the presentation, stands for regular season. To the right, a more sophisticated view, but essentially exact same information, is your Chicago Bulls current roster of players for the 2022 season. And again, this is on the Tableau platform. So you can get very similar results in very similar methods, but one is more direct facing with the database itself for the collection in this case, and the other is more analytical within Tableau. Here we see the second use case, which reads, you would like to see the team's net best and worst performing players during the regular season per their individual Raptor total statistic. So to the left, we came up with a script, and this was an output from MongoDB's Compass aggregation pipeline tool. It essentially was a little too big of a screenshot to include, so I had to transfer it over to Notepad++. But it essentially is the script as follows. It is segmented into the dollar project, dollar match, and dollar group pipeline segments, all dictating the various kinds of filters that should exist, such as the team, the Chicago Bulls, the season that you're interested in being the latest, 2022, and the regular season type, for example, RS. And it also shows the kind of data that you want to see, primarily just the name, the team, what season, etc. And at the bottom, you can see that we are only interested in the maximum and the minimum Raptor statistics. So we go ahead and group those into their own field, max Raptor and min Raptor. And we get the following pipeline output. As you can see more in the middle left, it says it is grouped by the team. And you can see that within the team, the highest Raptor score is a 512 or 5.12, and the minimum of negative 33.5. And we can verify this on Tableau in a more nicer looking graph or a spread of the various Raptor stats, and we can verify that the most positive one is Alex Caruso with that 5.12, and the player that is not performing as well is Mac McClung with a negative 33.5. Moving on, the next use case reads as follows. You would like to see the team's best to worst performing players on offense in descending order. So, similar to before, within MongoDB Compass GUI, we set the following filters for the season that we're interested in, the team, and the season. We also set what kind of fields we are interested in seeing and which ones we are not. Particularly, we are not interested in seeing the underscore ID or the object ID. And we want to sort things by the raptor underscore offense statistic or field in descending order, hence the -1. And below we see the output that is produced on MongoDB Compass. That player in question is Jordan Bell with a Raptor offense rating of 28.6997. So that is the best performing. And then we can see on the right on Tableau, we can verify that Jordan Bell is in fact the best performing with a 28.7 rating. And if we would keep scrolling on Mongo all the way to the bottom of the documents, we would see that, as we can see on Tableau, Mac McClung also comes in as the worst ranking player on offense with a negative 13.7 rating. So similar to the previous scenario, this scenario, you would like to see the team's best to worst performing players on defense in descending order. Essentially, the screenshot is pretty much the same, all except for the sorting field, in which case we are interested in the Raptor underscore defense field in descending order. And now we can see that at the top, that is the best performing, Marko Simonovic with a 6.48 rating. And if we scroll all the way down within Compass, we would see the worst rated, that being Jordan Bell. And we can verify this information onto the right within Tableau with the following list view. Again, Marco is at the top, as expected, and Jordan Bell has the worst rating with a negative 34.69. Next, a slightly different scenario. A rival team in your conference, the Toronto Raptors, are interested in trading with your team. They are offering a veteran point guard, Fred VanVleet. You want to look at his total Raptor stats to observe his performance in both the regular season and the playoffs. So here, you can see on the left a similar script to before. Again, it was a little too long, but here we used, again, the Compass aggregation pipeline feature to create the various different segments to get to the average Raptor score for Fred VanVleet. We include a project, a match, and a group segments. We are interested primarily in all the information except for the object ID and the player ID, as that is superfluous information. We are then interested in the player in question, Fred, and the latest season to see whether his stats are good to help our team out the next season. We are then interested in calculating an average Raptor score, so we create that field and we give it a dollar average calculation on the Raptor total field. This then produces the following pipeline output to the right, which is an average Raptor score of 2.62. Then moving to Tableau, we can create a couple of views to show what Fred's average Raptor score could be. In the first, we can show what his regular season score or Raptor total score is, which is a 4.726. And in the postseason or the playoffs, the score does dramatically drop to a 0.523. If we average those out, we do get the number 2.625 as seen in the next view. The last use case we want to explore is the following. To make the playoffs next season, you need to attract a big name free agent this offseason. So you look at the 10 best net Raptor rated players in the league with a minimum of 5 games played, which calculates to approximately 240 minutes played, or MP, as it is seen in this particular set of data sets. So to the left again, we show the GUI, the Compass GUI with the various fields we are interested in, which ones we are not, denoted by a 0, the underscore ID and the player underscore ID. And we want to sort by Raptor total in descending order. Below, we see a small screenshot of what a simple shell script would look like, that being season setting it to 2022, season type, regular season, and minutes played because we're interested in a player that is not injured and at least plays a good amount of games or has a good amount of productivity. We want to give him at least a 240 minimum playing time. So we use the $ greater than equal to 240 minutes played. To the right, or the bottom right, we see a list of the top 10 NBA players that follow these criteria. We also set a limit to the 10 documents in this collection, hence why we get numbers 1 through 10. First being Nikola Jokic, and the last one being Kevin Durant. We can verify this information on Tableau as seen in the above view. Once again, we can see Nikola blowing the competition away with an average rating Raptor total of 14.86, and at the bottom, Kevin Durant with a rating of 5.65. These are all excellent scores, so any of these 10 players, particularly the number 1 player, would be a great find in the offseason for your team. So, in summary, like many other sectors, the sporting world is adopting and leveraging big data and analytics to differentiate and gain a competitive advantage. During this presentation, we observed how big data and analytics tools like MongoDB and Tableau can be leveraged in the sports industry to handle and analyze large and complex datasets. Raptor data is a new and trending statistical method being used to evaluate and run NBA teams today. In conjunction with previously mentioned tools, sophisticated and comprehensive methods like Raptor can be utilized to build, evaluate, and plan for many different scenarios or desired outcomes, like evaluating your players, scouting the trade and free agent markets, etc. And thus, this concludes my presentation. Thank you for listening and sticking around. Hopefully you learned a thing or two about big data, analytics, and the NBA Raptor statistical method. Thank you.